Hey, how's it going? In this video, I want to talk about superconductors and what they are. With our changing world that we are living in currently, uh, with electricity, making changes in the way how we are living our lives, perhaps worth bringing everyone's attention to superconductors. And there are a lot of changes, or at least there are a lot of people who are working on a lot of changes within the industry, how we can improve the way how electricity works and how we are consuming electricity. Superconductors are materials that conduct electric current with zero electrical resistance. When material becomes superconducting, it can maintain a current indefinitely without losing energy to heat, making it highly efficient for a wide range of applications. If anything, there's a large chain of different parts that need to be taken into effect. I don't know who sometimes I'm communicating with, right? If I would bring to very basic level to understanding, right? So there are some scientists up there who are doing great works, right? Take five on this one, right? Potentially there are ways how energy can be produced in the first place, right? Once you produce energy, you need to move that energy from point A to point B, as well as different appliances, how and what the how from all powered machines, right, or petrol or diesel, whatever case may be, right, powered machines, or moving to electricity, as well as some of the use cases, right. But either way, once electricity is being moved from point A to point B, how that electricity is being moved within the supply chain. So there is a lot of pieces, right? So there is perhaps 20 different pieces potentially, and different, perhaps even more problems out there for people who are always looking for new opportunities, right? So superconductor is just one opportunity out there. So for people who are interested, if they were to study this subject for a very long time, perhaps a couple of weeks or so, they might be able to come up with better solutions, right, and offer a lot of value to large groups of people. Were recently a lot of scientists who have published a lot of work out there that they have made some parts levitate in the air, right? But that's not enough. That some scientists managed to do that. Other people need to replicate this process, right? So that's where problems come into play. How they manage to make those pieces levitate, that's great, but others needs to be able to replicate this process. Superconductors are materials that can conduct electric current with zero electrical resistance, or at least that's a target. When material becomes superconducting, it can maintain current indefinitely without losing energy to heat, making it highly efficient for a wide range of applications. So that would be perhaps a target. I don't know, the Area 51 or what's happening there, as well as some of those scientists up there, as well as how they are looking to achieve that with water potentially, or different materials, how they can potentially reduce temperature. So there's a lot of work done up there within the space. I have done a lot of work myself to try to understand what current ways how people are looking to achieve that, as well as have read a lot of books on science movies and action movies. I have watched a lot of those as well. Zero electrical resistance. Superconductors exhibit zero electrical resistance, which means they can carry an electricity current without any energy loss due to resistance. This property is stark contrast to normal conductors like copper, aluminium, which have some level of resistance, and those despite energy as a heat. So that if we were to come up with this solution where we would not necessarily need to buy more copper from some of those governments out there, buy from shell company will not necessarily support people up there, not necessarily doing great things, right? So that's one of the obstacles that we might be able to resolve with doing this particular task by solving this particular problem. Critical temperature. Most superconductors only exhibit their superconducting properties at extremely low temperatures. At least that's one of the ways how that can be accomplished, right? The temperatures at this material becomes superconducting is known as its critical temperature. There are two main types of superconductors. Type 1 superconductors, these materials have single, well-defined critical temperature and they expel magnetic fields, then they become superconductors. I think something in the hospitals, like I don't know, I have those large machines and the way how, but currently the way how people can potentially get the same results without not necessarily that high tech equipment, large high tech equipment. Perhaps there would be some potential there. Type 2 superconductors. Type 2 superconductors have more complex phase diagram with multiple critical temperatures. They can tolerate certain amount of magnetic flux while remaining superconducting. So perhaps that would be type 2. Perhaps if we were to develop any of those projects, that would be potential there. If anything, perhaps people out there already working on that. So if anything, I would just like to bring more attention to it. Meissner effect. When superconductor transitions to the superconducting state, it expels magnetic fields from its interior. This is known as Meissner effect. As a result of superconductors are ideal for applications involving powerful magnets, as they have generated strong magnetic fields without energy loss. But potentially that would be way how we can use to move vehicles from point A to point B, right? If we were to design anything interesting. So perhaps trains, or perhaps you could use superconductors to almost like a levitate, right? I don't know about weight, I don't know all those physical challenges that would be there to overcome, but perhaps there would be a lot of use cases how we could be implemented initiated in the real life, right? But I'm interested. Some people are working on that, right? From electricity, perhaps, and by using large and strong magnets, how we can potentially move things around. Applications. Superconductors have wide range of particular applications, including MRI machines. So it's something that I mentioned, as well as I have seen some of the projects there. Superconducting magnets are used in the medical imaging machines, MR, to create high strength and highly stable magnetic fields. But perhaps if we were to come up with a better way of doing it, perhaps so it's impossible if anything. So we'll like to acknowledge that it's impossible to do. Now we need to optimize perhaps processes up there. Practical accelerators, superconductors, magnets are essential components in practical accelerators like a large hadron collider to guide and focus practical beams. Power transmissions. Superconducting power cables can be developed to transmit electricity over long distances with minimal losses. Perhaps if we were to build some of that, because of the noise pollution, right? If we were to build a lot of electricity, like a wind on the sea surface or whatever case might be, and we were to transform or move the all electricity from point A to point B, there's a lot of use cases there. Magnetic levitation. Superconducting magnets are used in magnetic trains for frictionless high-speed transportation, as well as perhaps there would be a lot of savings there. So a lot of use cases. If anything, I myself I'm excited. I would be excited to use any of that technology up there. So there are some projects, but I'm not entirely sure. I don't know that much. I have seen a lot of prototypes, right, but not necessarily projects themselves. Perhaps it's worth covering with the future videos about some of the French companies out there that do putting very strong large engines in some of the trains of the it's worth covering those videos. But yeah, so far none of the trains that I know are levitating. High energy consumption. One major drawback of many superconductors is that they require extremely low temperatures, near absolute zero, to maintain their superconducting state. This necessitates the use of cryogenic systems, which consumes a significant amount of energy. Yeah, I have seen those. So the way how they're producing those, that's not necessarily optimal comparing to copper wire and the way how electricity is being used to transform now from point A to point B. And to add on top of that, they might use some of those other additional technologies like cryogenic systems just to maintain absolute zero, close to absolute zero temperatures. So it's not the best or most effective way of doing it, but there is so a lot of people already working on this subject. Technological challenges. All true superconductors have enormous potential. There are still technological challenges to be overcome. These include finding superconductors that operate at higher temperatures, i.e., close to room temperature. So ideally, that's what most of people are looking for. Perhaps we need better materials, right? In different places. We haven't looked everywhere. Developing practical and cost-effective cooling solutions. It's another option, and improving the mechanical properties of superconducting materials. So perhaps there's three areas in particular that could be addressed for any people out there who have access to different materials or different technologies to work on. For people out there who are interested in learning more, I would highly recommend to purchase this book. I have put all my knowledge when it comes to body and maintaining, improving, as well as other areas would be perhaps what food you should eat, rest periods, as well as working out. Myself, I have done it professionally, so have all qualifications. I don't know. Sometimes when I'm reading some of those books, some of those books are prepared for general audience. But this particular book, I would begin by sharing a lot of information for people out there who are at a beginner level, and I would progress into more challenging concepts for people out there perhaps who would like to take their hobby and progress into career and how to build on top of that. So I'm sharing a lot of information for people out there who are interested in learning more. You can find it in the description below as well as top retailers has it. Researchers continue to investigate and develop new superconducting materials and technologies to expand their use in various fields and address the limitations associated with their low temperature requirements. Thanks for watching. I'll see you in the next one.